All right, 12.3 is getting into naming of these compounds. Um, I'm going to give you pretty much most of the rules. There's lots of little tiny little rules here and there. It's all about what ifs. What if this? What if that? I'm going to go over the main ones. As you do homework problems, you might come across maybe one or two more, um, but we can definitely talk about it in class. All right. I'm not going to make this complicated, and I'm not going to give you complicated structures. I just want to make sure you know how to name a standard organic molecule. All right, and this system is called the IUPAC, which stands for the International Union of Pure and Applied Chemistry. There have been several meetings. I think the first one took place in the 1800s. What happened, or what was happening, is you've got science happening all around the world starting in the 1800s, like the scientific method, the discovery of atoms and stuff like that. Big stuff, was happening in the mid to late 1800s. All right, and what was happening was people in America had their own way of doing things, not only just how to measure stuff, weigh stuff. All right, everything was like the English system, pounds and stuff like that, but we also had our own way of naming things. And then someone in Italy, all right, all the scientists in Italy had their own way of naming things and doing their, all their weights and measures. And then people in Japan had their own way. People in Russia had a different way. People in England had a totally different way. Every country had their own way, and it was kind of confusing. Imagine if you are a scientist in America and you're reading a paper from Russia, all right, and they are using weird ways of naming things, and you're just sitting there like, I don't even understand what's going on. So they wanted to standardize. The whole world wanted to standardize science. They wanted to make one rule for how you measure things, which is the me- metric system. That's why we use grams and liters and a kilometer rather than miles and stuff like that. All right, but also naming organic molecules. We wanted to come up with a very systematic way where if I have a structure in America, I name it with the set of rules that Russia and Japan and England all name it under the same rules. And that's what this IUPAC implies, the International Union of Pure and Applied Chemistry, right? International meaning international, our whole entire world, and it's a union, okay? So these rules are the same rules that everybody in the whole entire world are learning on how to name organic molecules, all right? So this is the system that we're going to learn in order to name these. Now, the common names like the isopentane, things like that, that's just American stuff. Or, I mean, isopentane is used like so often that actually a lot of other countries actually use it. But again, a common name is a common name. It's not something that there possibly are other countries that don't use that name. Okay, so we're going to use this system so each compound is unique and you can easily come up with the name. And here's kind of especially in drugs, drugs have three different names. There's the IUPAC, or what's called the systematic name. This is the system that we're going to be using. All right, 2,4,2-methyl propyl phenyl propionic acid. Okay, crazy name. What in the world is this thing? Well, there's a generic name, which is a lot easier. It's called ibuprofen. That's a lot easier to say. You know what I'm saying? Like if you're, you know, let's say you've got a test coming up and you got a splitting headache. Are you going to ask your friend, hey man, do you have 2,4,2-methylpropylphenylpropionic acid? No. You're going to say, do you have ibuprofen? Okay? And a lot of the times, the generic name, they take certain pieces of these names and do them. Okay? Um, like so the ibuprofen stands for isobutyl. This 2-methylpropyl for short is an isobutyl. Okay, because if you notice, it's propyl is 3 carbons and methyl is 4 carbons. So this group is actually called an isobutyl group. That's where the ibu comes from. All right, and the profen you can kind of figure out is probably coming from this this propyl phenyl, profen. All right, but an F instead of an F instead of a PH. So that is actually how they got this name. They looked at the name and said, hey, this is an isobutyl. So how about ibu and then profen? Hey, ibuprofen. That's kind of cool. All right. This is not by chance, guys. This is how these things work. All right. Oh. Um, and then companies have patents on this, and they come up with trade names. Like one company has Motrin. I don't know if it's like Bayer or Merck or whoever. So let's just say Merck uses Motrin and Pfizer uses the word Advil. I don't think it's Merck and Pfizer, but I'm just saying one company is going to call it this, another company is going to call it that. And these names are basically not a scientist. It's not a scientist. These usually come from a scientist. All right. These names usually come from uh, a marketing agency or like the business people of the company where they don't know any chemistry. They're just like, hey, let's just Motrin. That sounds like a really cool name. You know, Advil. Hey, we got a V in there. How many words have V's in it? How cool is that? Okay, so that's kind of where the trade name comes from. Okay, well, moral of the story, this is what we're learning. All right. Okay, so to name the okay, so we're gonna first learn how to name alkanes. Now, most of these rules will go chapter by chapter, and we'll kind of take these rules that we learn in this chapter and apply them to chapter 13, chapter 14, chapter 15, and so forth and so forth, and so on. There are always three parts to a name. There's the prefix, there's the parent, and there's the suffix, which is the functional group. Well, what functional group are we learning in this chapter? Alkane. So our suffix in all these molecules are going to be ane. The parent is the longest continuous chain of carbons. So meth, prop, bute, pent, eth, hex, hept, oct, non, dec. That's what this is. And then the prefix are the things hanging off of the chain. Okay, so if I have a long chain of, let's say, 5 carbons and I got a bunch of carbons hanging off of it, that's the prefix. Okay, so let's start with the parent. The parent indicates the number of carbons in the longest continuous chain of carbons. The suffix is the functional group, which in this case are anes, which is not really a functional group, but it's the class of compound. And then the prefix tells you the location of the substituents hanging off of it. Okay, so this is just a bunch of words here. Carbon substituents are called alkyl groups. Anes, let's see, each alkyl group has a bond. Here, let me just kind of give you an example just to kind of show you. Okay, let's say we take this molecule. Okay, let me erase it so it looks a little better. Okay, so there's two things. The first thing you want to do is look for the longest continuous chain of carbons. Now, we're going to go through this in slides. I like to repeat myself a lot. I don't know if you've noticed that, but that's the best way to learn is repetition. So I'm going to kind of give you kind of the overview, and then we're going to go into it much slower, and we're going to do it again. So the first thing you do is you look for your longest continuous chain of carbons. Okay, so I usually start on the left and just count. So 1, 2, 3, 4, 5. That's 5 carbons in a row. Or I can go 1, 2, 3, 4, because remember, kinks don't matter. As long as these carbons are hooked to each other and I keep going in a continuous fashion. That's what's meant by longest continuous chain. Here's another one, 1, 2, 3, 4. Here's one, 1, 2, 3, 4. And then here's one, 1, 2, 3, 4, 5, 6. That is 6. That's the longest continuous chain. That is what we call our parent chain. 6 carbons. That's the parent. So if it's 6 carbons, what does 6 carbons start with? That was hex. All right, this is an alkane. So this is some sort of hexane. Well, what's the prefix? The prefix are these groups hanging off of our chain. This is a methyl group. Okay, that's where this is. An alkyl group, an alkyl group are groups that where a hydrogen has been replaced with a carbon group. It's not part of our parent chain, it's things hanging off of our chains. Those are alkyl groups. And those we end with YL. So this is a 1 carbon chain, so it's a meth, and in particular this is a methyl. That's a methyl group. And this is a methyl group. Okay, so the prefix, I'm going to give it to you now, okay, but we'll talk about how we name this. So the name of this is going to be 3,3-dimethyl. Okay, why is it 3, 3? Because here's my carbon chain. 1, 2, 3. I'm sorry, not 3, 3. That's my mistake. That should be 3, 4. So 1, 2, 3, 4, 5, 6. My methyl groups are on the third carbon and the fourth carbon, and I've got 2 of them, so that's the di, and it's a methyl. So 3,4-dimethylhexane. That basically means I have a 6-carbon chain, continuous chain, and at the third carbon and the fourth carbon, I have methyl groups. That's how you name it. Okay? So we have the prefix, the parent, and the suffix. Now, we're going to do this all over again, but I just kind of want to give you a heads up. Okay? Here they talk about alkyl groups again. So remember, alkyl groups are just these groups hanging off of the chains. They don't have to be methyl. They could be an ethyl group. So if I had if I had whatever, a long chain, and I had a CH2, CH3 hanging off of my chain, that's an ethyl group. What would be called if I have 1, 2, 3, 4 carbons hanging off of it? That would be a butyl group. Remember, 4 is butyl. That's a butyl group. Okay? So here are common names of alkyl groups: methyl, ethyl, propyl, butyl. Once we get to 5 and 6, since these are so big, they're probably part of your longest chain. You rarely see anything bigger than 3 carbons. That's kind of the part, but sometimes you will see butyl. But a pentyl group, hexyl group, I mean, those are so big you rarely see those. But it's just basically showing you these are the names of them. All right, so let's say this is my longest chain. It's not really important how many carbons. If I have a CH3 here and a CH2, CH3 here, and a CH2, CH2, CH3, this is a methyl group. This is an ethyl group. This is a propyl group. Okay, and this would be my parent compound, whatever it is. But don't be fooled. Your parent compound might not be in the straight line. It might be kinked. Okay, so here we go. Let's do another example just to kind of show you. All right, first rule, step 1, find the longest continuous chain. So you have a molecule. My longest chain is 1, 2, 3, 4, 5, 6. 6 carbons. If I count this way, this is like 1, 2, 3. Obviously, that's very short. Or 1, 2, 3, 4, 5, 6. In this case, it doesn't matter which carbon you start from. Okay, you're going to get the same answer. That usually happens. Okay, so longest chain. It does not have to be horizontal. That's what I was kind of implying. Notice these are all the same molecule. All right, this is 1, 2, 3, 4, 5, 6, but your chain might look like this. 1, 2, 3, 4, 5, 6. It's continuous. There is no breaks. Okay, like I can't go in a straight line and then I break up to here. This is a substituent. This is also 1, 2, 3, 4, 5, 6. These are all the same compound, guys. All right, it's called 2-methylhexane because the methyl is on the second carbon, so they're called 2-methylhexane. Okay, so it doesn't matter if the chain is straight or has bends. All 3 examples below are 6 carbons in the longest chain. All right, now the question is, we have to number the chain. Where do we start numbering? Well, it'd be nice if I said you just start from the left. Well, that might not necessarily work. All right, what if the molecule, I'm going to draw the molecule like this. This is the same molecule. Don't be fooled by the structure. 4, 5, 6. Aren't all these the same molecule? All right, if I were to take this molecule and just flip it over, this methyl group would be on this side. Okay, so where do I start counting? Number the atoms in the carbon chain that gives the first substituent as the lowest number. Okay, so what does that mean? This is a substituent. I can either start numbering on the left side or the right side. Okay, if I start numbering on the left side, my substituent ends up on carbon 2. If I start numbering on the right side, my substituent ends up on carbon 5. Well, which number is lower, 2 or 5? 2 is lower. So this is the direction I'm going to start numbering. This is carbon 1, this is 2, this is 3, this is 4, this is 5, this is 6. Let's say I gave you this compound instead, this one up here. Where would you start numbering? On this side or on the right side? You would start numbering here. This is carbon 1, this is carbon 2, this is carbon 3, this is carbon 4, this is carbon 5, this is carbon 6. You don't just start on the left side. You have to look at your molecule and determine which side is the substituent closest to. All right. Then you name the substituent followed by the parent. You also use hyphens and commas in between them. Okay, so name and number the substituent. So this is a 2 hyphen methyl. All right, hyphens are between numbers and words. Commas are between numbers. So if I have like a 4 and a 5, right, like how we saw in the first example. Okay, every carbon belongs to either the longest chain or a substituent, but not both. Kind of like that. I've never used that, but I kind of like that. It's either a substituent or it's the parent. Can't be both. Each substituent needs its own number. Okay, if 2 or more substituents are identical, use the prefix di, tri, tetra, or penta. So, okay, so these are the Latin. I believe it's the Latin prefixes. Okay, so make sure you use like the example I gave down here, back here. Notice 3,4-dimethyl because there are 2 of them. Okay. So let's say we have this molecule. Okay, let's say we have this molecule. Our longest continuous chain is 1, 2, 3, 4, 5, 6. That's a substituent. That's a substituent. I have a methyl at the 2 and I have a methyl at the 3. So this is 2,3-dimethyl hexane. All right, 2,3-dimethyl hex because it's 6. Make sure you have these memorized. Okay. So combine alphabetize. We haven't talked about this yet because we haven't seen an example. I think there's an example next that we'll talk about that. But basically, you combine the numbers and the parent and the suffix. So let's say I have an ethyl substituent. Let's say I have a long chain, and I've got an ethyl group, all right, and I have a methyl group. Ethyl group has 2 carbons, right? CH2, CH3. This is ethyl, and this is methyl. Okay, it doesn't matter what the numbering is. The way you name this is you always name the substituents alphabetically. So ethyl is going to come before methyl when you name it. And I'm going to show you an example of that. All right, make sure you have the number. There must be 1 number for each substituent. Separate numbers by commas and letters by dashes. I already talked about that. All right, so 2-methylhexane. We already talked about that. Dimethylhexane. Okay, here's an example. IUPAC name. What I want you to do, put the video on pause. Put it on pause. See what you come up with. Don't worry if you get it right, because there's that rule in here that I taught you about putting it alphabetically, which we haven't really seen yet, but see if you can figure this out, okay? So in 3 seconds, put this on pause. 1, 2, 3, go. Welcome back. If you did not put it on pause, then put it on pause because I'm going through it right now. So first thing, longest continuous chain. That's the first thing you do. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. So it looks like 8 is my longest chain, and it so happens to be the straight part, so that makes it easy. Okay, so it's 8. So therefore, what's the class of compound? So it's an alkane, it's 8, so it's an octane. This is a type of octane. So here's a substituent, here's a substituent, and here's a substituent. This is a methyl. This is an ethyl because it's 2 carbons. And this is a methyl because it's 1 carbon. All right, so now we got a number. Let's see, if I start on this side, 1, 2, all right? If I start numbering this way, 2 gets a substituent. If I number this way, 1, 2, 3. 3, the 3rd carbon has a substituent. So I'm going to start numbering this direction because this is the side closest to a nearest substituent. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now in naming this, I've got a dimethyl and I got an ethyl. Now, they don't tell you this, which you would have no idea because they didn't tell you this, and now I'm just realizing it. This di, tri, tetra, these things are not used alphabetically, not used when you alphabetize, not used alphabetically. Okay, you don't use the di, tri, tetras. Do they say that in the slide? If they don't, I'm going to have to add that in the future. Yeah, they don't say that. So that's why you have me, because I teach you that. There you go. All right, so di, tri, tetra is not used alphabetically. The M's and the E's are used alphabetically. Okay, so the name of this is going to be 5-ethyl. Okay, why ethyl first? Well, E comes before N alphabetically. Okay, 2,6-dimethyl. Okay, remember, it's not based off of the D, it's based off of the M and the E. Octane. Now, if you got this, awesome, man. Awesome. You figured it out without knowing this rule right here. All right. But basically, we're alphabetizing the E versus the M. All right. You have to put both numbers. You have to tell me which two carbons have that methyl. You can't just say, like dimethyl. You have to say where the dimethyls are. All right. Let's stop the video here because that's already 20 minutes, 21 minutes in this video, and we'll pick it up in the next video.